So in this example, we've got two forces that we're given here, P and Q. They're acting on some particle. We've got magnitude of P is 10 newtons. So I'm going to add that to the diagram. We're also told that Q has got a magnitude of 8 newtons, so I'm going to add that as well. They're acting at angles. We're trying to work out the magnitude and direction of the resultant force. So the key thing of this is realising and remembering that forces are vectors. So this question really wants us to work out the resultant vector. So that means we're going to be getting both of the forces, adding them together, and then from there we'll be able to work out like the magnitude of the vector we get. So if we start with P, we've got horizontal component here, we've got a vertical component here. So if we use the rules we've had before, that horizontal component is adjacent to 45, so it's 10 cos 45. The vertical component is the opposite to 45, so it's 10 sine 45. Both of those turn out to be the same thing. If you do 10 times sine 45, you get 5 root 2, and in fact 10 cos 45 is also 5 root 2. So we've got both of those. So in other words, as a vector, the force P is 5 root 2, that's the horizontal component, and then 5 root 2 also for the vertical component. We want to do something similar with Q. So Q, the vertical component here, that's opposite the 30, so it's 8 sine 30, which is equal to 4. The horizontal component is the bit here, that's the adjacent side, so it's 10 cos 30, which is equal to 5 root 3. So Q, as a vector, we've got the horizontal component, which is 5 root 3, and we want the vertical component. So just notice it's going downwards here, so from Q we've gone down, and so that means that's minus 4 rather than just 4. So resultant vector is just adding those two things together. So P add Q is going to be equal to 5 root 2 add 5 root 3, and the vertical component would be 5 root 2 subtract 4. So I've left them as exact values just for the sake of keeping things exact for the time being. We will need to get approximations in a moment. So to get the magnitude, that's the Pythagoras bit. So I'm going to get the decimal approximations for these. I think that will be easier for us to work with for the time. Okay, and so those are as far as we've got 15.731 horizontally. Then vertically we've got 3.071. So to get the magnitude of force, as I said, it's just Pythagoras. So the magnitude is going to be the square root of 15.731 squared plus 3.071 squared. And that's equal to 16.0 newtons. So it's newtons because it's force. It's 3 significant figures. And the other thing that we wanted was the direction of the force. So if you just sketch out what P plus Q would look like, it's going to be something like this. Because we've got the 15.731 here, 3.071 there. When we're talking about direction, we would want to just work out some kind of angle. So I'm going to work out the angle here. So we've got the opposite side is 3.071. This one's the adjacent. So therefore, tan theta is equal to 3.071 over 15.731. So if we just do inverse tan of that, we'll find what theta is. And I'm getting that to be 11.0 degrees. I'm just going to put above the horizontal just to be clear about which direction I'm referring to. And that's it.